Hello everyone, welcome to data structure class. In today's class, I am going to explain the next type of queue, that is circular queue. Before that, I will explain uh, just like a review what is a queue. Queue is an linear data structure where elements can be inserted from the one end, that is rear end, and deleted from the other end, that is called the front end. In that we have seen three operations. First is inserting an element into queue, then deleting an element from the queue, then displaying the elements of an queue. So how to insert the element into queue? By we are inserting from the rear end. This rear initial at the position -1 means before this 0. Here the rear will be there. Rear is -1. Then if we insert the how to insert the first element into the queue? By using rear only. We increase the rear value from rear equal to rear plus 1. That becomes -1 plus 1. It becomes 0. We come at this place. Okay. When at that time we can insert the first element, that is 10 will be inserted at 0th location. Then keep on we increment the rear value when we are inserting new element into the queue. So next element will be inserted at 20, then 30. So keep on 50 will be stored at the fourth location. That time the queue is full. So how to find the queue is full? Whenever the rear reaches the queue size -1, here queue size is 5, -1 is 4. So rear equal to queue size -1, that time the queue is full. We can't insert few more elements into it. In that way, we go for inserting the elements. Then next step is how to delete an element from the queue. In order to check deleting the element from the queue, first check that whether queue is empty or not. If it is empty, we are not it is, no need to delete any element. So how to check that queue is empty? As I told, initially rear will be at -1 and front will be at 0. That time no elements are inserted. That time you can say it is an empty. When rear is -1, front is 0, indicate that front greater than rear, that is 0 greater than -1. If that condition satisfied, that time it is an empty queue. If it is not empty, how to delete an element from the queue? From the front end. So front will be from the front end initially position 0, that is queue of front. Queue of front will be 10 will be deleted. Then front plus plus, it will move to the next element. Okay, this is how we delete the element from the queue. Then displaying the elements of the queue will be from front to rear. I equal to front, from the front first end to the last end. This is how we perform insert, delete and display operation. Then we have seen calling all three functions into the main function by using switch. In the switch we read case 1 for insert, case 2 for delete, case 3 for display. Okay. Then what is the disadvantages of a ordinary queue? The ordinary queue during delete operation, if we consider the first element is deleted, like in the 0th position 10 is deleted, then from the 1 position 20 is deleted. Then even though the space is available, if you want to insert any element, it is not possible. Why? Because by inserting the element we check the condition. If rear equal to queue size -1, that is if rear equal to 5 minus 1 4, that time the queue is full. It is not possible to insert any element even though these two spaces are available. This becomes an disadvantages of an ordinary queue. In order to overcome this problem, we go for the circular queue. We can utilize these spaces. Uh, Even though the stack reaches to rear, we can able to insert the element at 0th and 1 position. See, in this example, here the all five elements are inserted. In order to insert the element, what we are doing, rear equal to rear plus 1. In that rear position, we insert an item. In this we have seen while performing inserting an element into queue. Okay, in order to move to next position in the rear, we go for in the ordinary queue, rear equal to rear plus 1, but in circular queue we make use of rear equal to rear plus 1 mod the queue size. Okay, initially rear will be at fourth position, uh, then here also it is at fourth position. If we move to the next value, uh, here rear equal to rear plus 1, it becomes 5, but here rear equal to rear plus 1 is 5 mod the queue size is 5. 5 mod 5 will get the 0. So we came to the front position, like we came at 0th position. And at same time here, in order to move to the next uh, front position, we make use of front plus plus, but here in order to move to next front position, again we go for front equal to front plus 1 mod the queue size. Okay, if I consider front is at 0, after front plus plus it becomes 1. Here also, if front is 0, 0 plus 1, 1 mod queue size. That is, when numerator is smaller than denominator, numerator will be the answer, that is 1 will be the front. Now in this way we increment the front position. Next, in this example I have deleted the 10, even though the first element is empty, it is not possible to add any new element to it because the rear reaches to the final position. Same as here I have deleted the element. Then if I make use of rear equal to rear plus 1 mod queue size, instead of it will move to 5, it will move to 0. Now here at 0 position we can insert the new element 60. Okay, the same thing can be represented by making use of like the same circular queue represented in the uh, single horizontal line. Okay, then again the front will be increased by making use of front equal to front plus 1 mod queue size. Earlier if I increase the front, that time 4 plus 1 it becomes 5, but now if I make use of the new equation, after increasing the value 4 will be moved to 0th location. Okay, so we can this empty space can be where earlier 10 is there, that is deleted, then the space is empty, here we can insert the new element 60. This is how we can overcome the problem of the ordinary queue. Then we can represent all of them in a single function. Initially check for the overflow, void insert a circular queue. Here I have taken a count equal to 0, means that initially when no items are there, we consider the queue is empty. Whenever we insert the uh, elements into queue, the count value get increased. So initially, if count equal to queue size, whenever after inserting the 5 element, the count equal to 5, that time 5 equal to queue size, that is 5, it is equal, we can say that it is queue is full. Then if it is not full, what we have to do, we have to increase the rear pointer, rear equal to rear plus 1 mod queue size. Now as I told, 4 plus 1 5, 5 mod 5 is 0, we came at 0th position, there you can insert the new element. After inserting the one element, again increase the count. Okay, this is how the circular queue insertion operation works. Then deleting an element from the circular queue. Again, if count is 0, indicate that no elements are there, that time it is return -1. The queue is empty. If it is not empty, directly we delete from the front end. Queue of front, whatever the value is there. For example, if now that front position 60 is there, 60 will be assigned to item. The item contain the deleted value. Then we update the front pointer. In the ordinary queue we make use of front equal to front plus 1, but here we can make use of the mod operation. Then update the count after deleting the elements, one element from the queue. Earlier if it is 5 elements are there, now it becomes 4, so you have to decrement the value. Then return which element that is deleted, return the item. For that sake I have taken, it is return type is integer because it returns a value. Then displaying an elements of an queue, Initially, again you have to check that whether the queue is empty or not. If count equal to 0, return -1. If it is not empty, then display the contents of an queue. So here I have taken, we always start from displaying from the front. That is I have taken I equal to 1, I less than equal to count. If 5 elements are in there, then count will be increased from 0 to up to those many values. Then I plus plus. Q of front. The front element will be the first element. It always starts from the initial value. So I am displaying uh, first element by using Q of front. Then increase the pointer after editing the after displaying the first element. Again we have to move for the second element, so update the front pointer by using front equal to front plus 1 mod q size. Okay, if earlier 0 is there, now it becomes 0 plus 1 mod q size. So the new updated pointer is 1. Display the value at position 1. Then next time it is 2. Key point will be done up to reaches to the final value. Okay, this is how circular queue works. Then in the next class, the next video, I am going to explain the double-ended queue. In the next Saturday class, I am going to explain uh, this concept. If you are having any doubt, till then go through the video. Thank you.